All right, in this part, we're going to go over solving absolute value equations and inequalities to start. So this first one, 19a, we have an absolute value equality, and kind of the first thing when you're doing all of these different parts for 19 is making sure that you are isolating the absolute value. So in this case, the absolute value is isolated. There's nothing in front of it. There's nothing behind it on that side of the equation. So I'm going to write or, and I like to put the original one on the right side. So 4x plus 5 equals 11. Or 4x plus 5 equals negative 11 on the left side. Because remember, if we take the absolute value of 11, then we end up with 11. If we take the absolute value of negative 11, we also would end up with 11. So that's why we have two possible solutions here. Now the algebra then is just moving over the 5 with subtraction. So we have 6, so x equals 6/4, which is 3/2. Or we have 4x equals negative 16, so x equals negative 4. All right, so do the number line. I'm going to put 0. Then I'm going to put 3/2, or 1.5, your call, negative 4. And remember, for absolute value equalities, these are just going to be points. All right, for the interval notation, I'm going to do braces, negative 4, comma 3/2, and then close the brace. Okay, letter B. Let's isolate this absolute value first. So subtract 6 to get 2 times the absolute value of x minus 9 is greater than 0. Divide by 2. Remember, nothing is touching the absolute value in terms of like what's inside it. 0 divided by 2 is still 0. All right, now this one is a little bit of a tricky one. Whenever you have 0, I'm going to write with my inequality symbol greater than. So greater. So I'm going to write x minus 9 is greater than 0. And on this side, I'm going to write x minus 9 is less than the opposite of 0, right? Because that's what we do is we do the other one. We change the inequality sign as well as make the sign of the number the opposite. But 0 cannot be negative or positive. It's neutral. So actually, I'm just going to keep that as 0. Okay? Now moving 9 over gives me x is greater than 9 or x is less than 9. Now watch what happens when we graph this, right? We've got 0. We've got 9. I'm going to do an open circle at 9. Greater than 9 is to the right of that. Less than 9 is to the left of that. So we have basically any number would work to make this inequality true, except because of that open circle, 9 would not work. So the interval notation is going to be negative infinity, comma 9, union 9, comma infinity. Okay, letter C. This one's a little bit tricky. I'm going to actually subtract 7 times the absolute value of x minus 4 from both sides. Think of it as like they are like terms. So that's going to allow me to do 10 minus 7, right, to give me 3 as the coefficient in front of that absolute value. Bring down the minus 5, bring down the 1. Now isolate, add 5. So we have 3 times the absolute value of x minus 4 equals 6. Divide by 3 to get 2. Absolute value of x minus 4 equals 2. So from there, I'm going to write or. So x minus 4 equals 2, or x minus 4 equals negative 2. X equals 2 plus 4, which is 6, or x equals negative 2 plus 4, which is positive 2. Draw the number line. There's 0, 2, and actually let me make my 0 a little farther over. 0, 2, and 6. I've got my 2 dots. And because this is an absolute value equality, we're going to be using braces again. Ooh, that was not a good brace. There we go. 2, comma 6. There we go. All right. Letter D. Letter D, let's isolate. So I'm going to add 5 to both sides to get 8 times the absolute value of x minus 2 over 5 is less than or equal to positive 8. Divide both sides by 8. Remember, I'm not touching anything inside that absolute value. So x minus 2 over 5, still inside there, is less than or equal to 1. Now I have finally isolated my absolute value. So the way that I do this is I look at my inequality symbol, which is less than. So I'm going to write and. I like to copy the one that is unchanged on the right side. And on the left side, I'm writing greater than or equal to, right? Switching the sign. And the 1 becomes a negative. From here, I do the same steps algebraically. Move that 5 over with multiplication. And then add 2 to both sides. So 7 over there, and x is greater than or equal to negative 3 over here. All right, draw the number line. Got 0, negative 3, we've got 7. These are going to be closed circles because of the or equal to. And because we have greater than negative 3, I'm going to start shading to the right. Less than 7, start moving to the left, and they meet, right, which matches my thought with and, right, a conjunction. So my interval notation will be bracket negative 3 comma 7. So any solutions in between those and including those would work. Okay, E and F, last two for this one. Let's go ahead and divide both sides by negative 4. Now hopefully you have alarm bells going off because we should change the inequality symbol to the other one if we divide or multiply by a negative. So that's going to be less than or equal to negative 2. And then I actually stop here and get ready to write my answer, right? The whole idea is, like we did in this unit, in unit 2, when you have that negative after your absolute value equation or inequality has been isolated, you really are only going to have one of two answers, right? In this case, right, no matter what we plug in, we're always going to get a positive compared to a negative number. And positive numbers, right, are never going to be less than a negative 2. So this will never be a true statement. That's a false statement. So if it's never going to be true, then we're going to write no solution. Now for F, I'm going to isolate by subtracting 6. So 2 times absolute value of x minus 9 is greater than negative 12. Divide both sides by 2. Now I'm not changing the inequality symbol here because I divided by a positive 2. So less than negative 6. But I am stopping because I have an absolute value inequality, and I notice that this again is a negative after I've isolated. So remember, these are always positive numbers, no matter what, compared to a negative number. And always positive numbers are always going to be greater than negative numbers. So in this case, no matter what I plug in for x, I'll always get a true statement. So this would be all real numbers would work. So like graphing it, right? If I were to graph it, it's the whole thing is going to work, right? The whole thing. So interval notation wise, I'm writing negative infinity to infinity. Okay, now let's move into systems. All right, so the last part of this video, I'm going to do graphing some systems of linear inequalities. The next part of these videos, so tune into the next one if you're looking for solving systems with 3 variables. All right, so if it's not in slope-intercept form, let's go ahead and do it. The first one is, we have y is greater than or equal to negative 1/2 x plus 3. Let's copy down the second one, and I want to make this become slope-intercept. So I'm going to move the negative 5x to become a positive 5x. Divide everything by 2, so y is less than 5/2 x minus 3. Okay, let's graph each of these. So we've got a y-intercept of positive 3. Slope is negative 1/2, so up 1, left 2. And down 1, right 2. All right, make sure you have your Falcon card for a straight edge on the midterm. All right, so I'm going to make this one a dotted line. No, a solid line. If you look here, it says or equal to. So that's going to be a solid line. My next one, the y-intercept is negative 3. And a slope of 5/2, so 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5, 1, 2. Go down 1, 2, 3, 4, 5, 1, 2 to the left. And this one is going to be the dotted line because it says y is less than, does not say or equal to. So I'm going to make this a dotted or a dashed line. Okay. Now the shading part, the way that I do it is I just decide where I'm going to shade for both of them and see where they overlap before I shade. So greater than, right, this symbol here, greater than is above. So I'll be shading above this line. And then for less than, the 5/2 x minus 3, that's going to be below the line. So they're going to overlap. I'll choose a highlighter. They're going to overlap in this area. All right, so that is number 20, letter A. Okay, let's do letter B. All right, the first one is not in slope-intercept form. X minus 3y is greater than or equal to -3. So I'm going to move the x over to become -x. But then when I divide by that -3, I've got to change the inequality symbol. And a -1 over a -3 is positive 1/3. And then -3 divided by -3 is positive 1. So I'll be graphing that one now. So y-intercept of 1, up 1, right 3. Or down 1, left 3. Make the line. It is a solid line. It says or equal to. All right. And then this one here, x is greater than 3, is a special case. That is a vertical line when it's x equals a number or x is with an inequality with a number. So I'm going to do a vertical dotted line because it's not or equal to at 3. Now, for greater than that vertical line, that's going to be shading to the right. So we're shading to the right. And then less than that 1/3 x plus 1 will be shading below. So they are going to overlap kind of in this bottom right area. Okay, and that is it for this letter B. All right. Again, don't forget to bring that Falcon card so you can help with your graphing. All right, and in the next part, we'll go into solving linear systems with 3 variables.